All right. Hello, everyone. Welcome to the next episode of the YugabyteDB Friday Tech Talk. I'm Kannan Muthukkaruppan, one of the co-founders at Yugabyte, and it's my pleasure to welcome Val Kulichenko to our session today. Val, would love for you to get started, introduce yourself, maybe what you do at Yugabyte, and then jump right into the topic. So thank you very much.
Thank you, Kannan. Hello, everyone. Yes, so I'm Val. My name is Val. I'm one of the product managers at Yugabyte. I work basically on everything related to data integrity and availability, which includes backup and restore, point-in-time recovery, xCluster replication, and recently I've been working a lot on basically like an ongoing project of creating a good DR solution for YugabyteDB based on xCluster application, and this is what I want to talk about today.
Yeah, thanks, Val. Let's jump right into the topic. Thank you.
Sure. So to start, I want to start with just a little bit of justification of why we need DR and why we're essentially building this product, right? And when we talk about disaster recovery, in a scope of different databases, and different databases actually use disaster recovery for different use cases and for different scenarios. Like if we talk about traditional databases, like single instance databases, they would often talk about disaster recovery in the scope of disk corruption, or maybe just the actual, instance failure. YugabyteDB is a little bit different in that regard because it's a distributed database built for high availability. So it is typically deployed across multiple nodes and often across multiple availability zones, which just basically means that you have multiple tablets which are replicated independently through the Raft protocol across those nodes. And if you lose even like a whole availability zone, the leaders are reelected and all the data is still available, right? So losing a whole availability zone or losing a single node will not actually make your data unavailable. So this is just ingrained into the design of the database. So the main question that we want to answer when working on disaster recovery in the scope of YugabyteDB is what to do if there is a whole region outage, right? It is a relatively rare event, but it still happens every now and then. And if we look at the reports from the cloud providers, it happens like every several months at least. So what do we do in that case? So first of all, it is actually possible to stretch your cluster across multiple regions in the same way as you would do that across multiple nodes or across multiple availability zones, right? That will actually achieve most of the disaster recovery goals, meaning that, yeah, if you lose the whole region, the data is still available. There is no downtime. There is no data loss, which means that you basically have zero RPO at all times. However, all that comes with the price of higher write latencies, right? So any update that you do to your data now has to go through the cross-region network, because that's the synchronous replication mechanism which happens under the hood. So for a lot of deployments, for a lot of applications, those latency numbers that you will get from such deployment are inaacceptable. So you want to essentially find a compromise between disaster recovery mechanism and the right latency that you have in the application. And that's what we are building right now. So we do have xCluster replication mechanism, which implements asynchronous replication of data between two clusters. And we're using that mechanism to create a disaster recovery solution based on asynchronous replication, which is optimized for lower latencies. So any update that you do in your database would happen within a single cluster, within the active cluster, right? And then it will eventually be replicated to the standby cluster, which is an independent cluster deployed in a different region. That means that you get your lower latencies that you're looking for. However, that also means that in case of a disaster, you will potentially lose some data, and I will talk about that in a little bit more detail.
And basically, like, I think that's the difference. I mean, in the stretch cluster approach, you're dealing with still a single cluster and synchronous replication within it. Whereas here, you're dealing with two clusters connected by this async replication mechanism. It's near real time, but it is not synchronous. So in the case of a failure, if up until then the network was healthy, the other cluster would be caught up to in a matter of seconds. So it's not going to be very far behind, but it's not synchronous replication. Yeah.
Exactly. Yes. Thanks, Kannan. So there are some new features, and I will go through all of them and also show a quick demo as well that help us to.
Yeah, maybe worth calling out, like Yugabyte's release convention, if the second digit is odd, like say 2.17, it's like more of a preview release. So the features that Val is going to be covering, just sort of the up and coming features in xCluster, are more of the preview release features. So they are not generally available for production usage. So I just wanted to caveat that. But and we expect a lot of this to get hardened over the next release cycle. So thank you.
Yeah, that's a big project, and we're actually actively working on it right now. So yeah, I didn't go through this. So there are some basic blocks like transactional reads on the standby cluster, right? So when we talk about active standby deployment, we usually assume that you can run read-only workloads on your standby clusters. And for that, we added transactional support in 2.17. And then there are some new APIs that I will cover that help us to manage the disaster recovery solution and also manage the failover workflows, which I will also cover in detail. So let's start with the transactional reads, right? So there is Yugabyte is obviously a transactional database, right? So when you execute your transactions on the active cluster, you want the standby cluster to essentially see the same result, right? And to make sure, we want to make sure that transactional consistency is maintained on the standby cluster, right? So prior to 2.17, what actually would happen with xCluster is that if you have a transaction that, let's say, updates 2 entries, 2 rows in maybe different tables, and those rows happen to be in different tablets, they could arrive to the standby cluster in different order, right? So it would happen that you not only in different order, but you can see, the standby can actually see only one of them, right? Because the standby cluster will essentially ignore the transactional borders of that transaction, right? So it's possible that you would see just only update A or only update B. So this is the old behavior that we have prior to 2.17. With the feature that we just implemented, we basically kind of close this gap, right? And we make sure that you either see both or you don't see either, which is exactly what we're looking for from the transactional consistency perspective.
Yeah, in some sense, yeah, maybe I just wanted to call out like the intuition behind this. Given that Yugabyte is a distributed database, the source cluster doesn't have a single transaction log to kind of pull from, right? The transaction log is also distributed. So in the older version, we were still only publishing committed changes on the standby cluster, but the ordering and the things could arrive out of order. So in some sense, one way to describe the old behavior was atomicity guarantees were single shard, right? So whereas with the new behavior, you get truly the multi-shard atomicity guarantees that either the changes to A prime and B prime are published atomically. So any reader can either see the before image or the after image, right? So, but not a jagged cut of the rows.
Yeah, and we have a similar problem with the ordering of transactions, right? So if you execute transaction A and then transaction B on the active cluster, you expect to see on the standby cluster, you also expect to see the same order of transactions, meaning that if you see the result of transaction B, you also should see the results of transaction A. So again, if they happen to be in different tablets, they could be reordered prior to 17, meaning that it was possible to see the update B without seeing the transaction A, which happened in the transaction that was prior to transaction updated the row B. Right. So this is the again, one more gap that we closed. And in the new behavior, we eliminate this possibility of seeing B but not A. So you either see both, you either see neither, or you see A but not B, because that is still possible, because that preserves the ordering.
Yeah, and I mean, it's a very small difference between the two examples. Yeah. Both are two row kind of examples, and the two rows live on two tablets. In one case, both the rows were changed as part of the same transaction, whereas here each transaction is a single row transaction, but there was sort of an expectation of ordering on the source cluster. And with the new version, we preserve that ordering. By the way, maybe this is a good point to take a couple of questions here, Val, that's coming from the attendees. So one of the questions is, in the transaction replication, do you check the pre-image of the row for conflict?
Pre-image of the row. I'm quite frankly not sure what pre-image of the row means.
Maybe one interpretation of my question is, maybe they're asking for like in a unit, when replication is set up in a unidirectional way, we don't expect conflict. So maybe this question is talking about bidirectional replication. So with transactional atomicity, I don't believe we really support bidirectional application, but with the more basic version, you can set up Yugabyte in a bidirectional replication, but generally that is approach is to be used with care, meaning normally if the application is, the best practice is the application is writing to different sets of keys in both directions, but if they do end up writing to the same key, our conflict resolution is simply latest writer wins semantics. So hopefully that answers the question. And to the other, there's one more question, which is like, well, does xCluster use change data capture or something else? Yeah, that's a great question, because Val, if you want to take it, go for it. Otherwise, I can add some color.
Yeah, so we do have CDC feature, which is a different feature and a separate feature from xCluster. And the way xCluster works is that we maintain write-ahead logs for every tablet, and those write-ahead logs are replicated to the standby cluster and replayed there.
Yeah. So maybe one color I would add is, in both cases, like change data capture and xCluster, yes, we are kind of like subscribing to changes happening in a source cluster. In one case, the target of this is another Yugabyte cluster itself, that's xCluster. Whereas in change data capture, it can be in many other formats, like in a end user consumable format to connect other microservices and so on. Under the hood, these two technologies do use a lot of common building blocks, because they're both in some sense tailing a distributed transaction log. So there's a lot of common functionality, and that is one of the engineers responded on the thread also. Yes, we replicate the transaction log to the target cluster, and change data capture also uses a very similar logic. So there are a lot of common building blocks here. Go ahead, Val.
Yeah, thank you. All right, so let's actually take a look. So these are like building blocks, right? So we support atomicity. So for us, this was like a prerequisite for the actual disaster recovery solution. Now let's take a look at the actual setup, right? So again, like xCluster is the underlying mechanism, but there are also several other things that you need to do to make sure that you have the actual DR setup. So first of all, there is currently a G flag. So if you want to try this feature out in 2.17, there is a G flag that needs to be set on both ends to essentially enable those transactional atomicity mechanisms. The G flag will be not required in the future when we have like the GA version. There are some design decisions to be made how it will actually work, but we definitely will not require a global flag, right? Like that. But now you have to set this G flag on both both clusters, on the active and on the standby. Another prerequisite is point-in-time recovery for all the databases that participate in DR that are being replicated, and I will explain shortly why we need that. We use that in failover workflows. Then you also set up bidirectional xCluster replication, and like I need to explain that, I think, because like when I say bidirectional, what I mean is that you set up replication from the active to standby and from standby to active. However, we always assume that updates only go to the active cluster. So active cluster accepts read-write workloads, while standby cluster accepts read-only workloads. So there are no conflicts. It's still like active passive replication, but you need to have xCluster set up both ways, again, for failover workflows. Because when you failover to standby, you want to replication go other way. So you need like initially have this set up. And then you also identify the, in this case, cluster in the US region as a standby. So you identify one of those clusters as a standby, and for that there is a new API in YBadmin, change xCluster role, which can be standby or active, and we'll see that in the demo how to use that. And I also want to make a note on what this standby role means, because there are actually two things this provides, and two reasons why we have this like designated read-only mode, standby mode. So first of all, it makes sure that that cluster is actually read-only, right? So I said that we assume that updates only go to the active cluster. So standby mode will actually enforce that. It's currently not implemented. So in the current implementation, it will actually accept updates. But in the future, standby cluster will be read-only, meaning that you cannot actually do updates there. So we enforce this kind of active-passive replication. And the second thing is a little bit more technical. It's about what we call save time. So if you have multiple updates happening on the active cluster, they can come to the standby in different order. So for example, if you have updates A, B, and C, you can have a point in time where standby received only A and C, right? But
so this example, just to be clear, A, B, and C, these three updates are not part of the same transaction. Am I correct?
Correct.
You're talking about three separate updates with commit, updates with commit. Got it.
Correct. Yes, these are separate transactions. So until the standby receives the update B, we cannot actually serve the update C, because that will break in this case, it will break the global ordering that we want to preserve, right? So which means that we actually only can serve the data that the standby received at the point in time T1 or before that, right? So that is what we call save time. And when you switch your cluster to standby mode, that will actually make sure that all updates which have the timestamp beyond T1 and greater than T1 will be ignored when you read the data. And that's how we preserve the consistency. And there is also the API that gives you that save time. And again, I will show you how we use that for failover as well. So let's look at the failover workflows, right? So when we talk about failover workflows, there are actually two that we kind of differentiate between. First of all, planned failover. Planned failover is the process of essentially switching active and standby roles. So this usually happens like during maintenance, as a fire drill. There are, companies may have internal policies, or there are also regulations that tell that you have to test your DR solution, let's say every 6 months, right? And what you do in that case is that you basically want to make your active cluster standby and standby cluster your active cluster. And the main requirement here is that you don't have the data loss, which we can achieve because there's no failures. So we want to make sure that happens. So the way you do that is you first stop the applications. I will really quickly go through like high level how those workflows happen. We will of course have more detailed documentation for them. So you stop the applications. And also, by the way, I will say that you have to stop the applications multiple times. We will relax some of those requirements going forward. But for now, we require that for pretty much any management operation. So you stop the applications, and then you wait for the replication drain to complete. So which means that you issue a special command through YB-admin to your standby cluster, and it will make sure that it gets all the updates and that the replication lag is 0. Right. So this way we make sure that the data in the active cluster, in the standby cluster, are the same, right? And once you get to that state, you can do the actual failover and you can switch the roles. So you demote the currently active cluster, which is US West in this example, to the standby cluster, and you do the opposite on the US East. So you make it the new active cluster. After which you can resume the applications. But now the US West accepts only read-only workloads, while the US East accepts read-write workloads. So this is the exact same setup, but it's reversed now, right? So the cluster on the right is the active one. The cluster on the left is the standby. So this was the planned failover, right? So unplanned failover is what we actually usually understand by disaster recovery, right? So this is the actual disaster scenario when your active cluster goes down or becomes unavailable for whatever reason, right? Maybe there is a region outage, maybe there is a problem in the cluster itself. So in that case, you want to switch the application to your standby cluster. And in this case, some data loss is acceptable, right? Because the replication is asynchronous and it's actually inevitable, to be more precise, right? So the way you do this, again, like very quickly through the workflow. So you stop the applications first again. Currently, this is a requirement. We'll see if we can relax it in the future. And then you use point-in-time recovery to restore your standby cluster to the safe time, right? So remember, so first of all, one of the prerequisites was that you have point-in-time recovery enabled, and that's why we actually need that. Because you essentially want to cut off all those like partially replicated transactions and transactions that are out of order, out of global order, to make sure that when you read from the latest time, you still preserve the consistency, right? Because when you switch to the active mode, you will start reading from the latest time. And to make sure that it's actually the safe time, you need to execute PITR to the safe time. So you will get the safe time using the new API, and then just use the point-in-time recovery to restore to that time.
Might be worth clarifying here, Val, like a question that comes here is how expensive is point-in-time recovery? And if I have like, hundreds of terabytes of data, what is the expectation from the user?
Yeah, so point-in-time recovery is based on in-cluster snapshots, which depending on the workload, they can provide some overhead in terms of like the disk consumption. But generally speaking, like a snapshot is, in most cases, it's just a set of hard links to files, so it's not a physical copy. So the overhead is minimal. And also for this particular use case, you don't usually need a lot of retention on the PITR, right? So having like one snapshot might be enough. So yeah, like there might be some overhead, which is generally speaking depends on the workload. So there is no like a strict formula that might help you estimate the overhead. But usually the overhead is not significant.
Exactly. Yeah. Basically, it's very true that it's not proportional to the amount of data, because the snapshotting mechanism is more link based, and it essentially leverages the multi-version concurrency control aspect. So in Yugabyte, older versions are retained for a little bit. So these two in combination means we can kind of roll the cluster back in its existing place to a previous point in time, so that you trim all the jagged writes that might have arrived from xCluster replication when this failure happened, and you kind of reset your point a little bit back in time, maybe, a minute or so back to get a clean safe time. And then it's a pretty quick operation, and it doesn't have to do with like, I have 500 terabytes of data, so this is going to take me a long time. I think there are a few more questions. Let's just go through that. Is xCluster supported in YSQL and YCQL both?
Yeah, so the xCluster itself is supported for both YSQL and for YSQL. However, the transactionality that we implemented into 17 is YSQL only. So these workflows are mainly applied to YSQL, but
Okay,
xCluster itself, like the data replication, can be set up for both.
Yeah, and in general, like basically for the single shard guarantee use cases, which was sort of the earlier capability, yes, it is supported in YSQL and YCQL, but a lot of the enhancements for transaction ordering and atomicity for multi-shard or multi-row transactions, that's primarily, it's still, like I would say, in preview release, right? Primarily on YSQL, although there's no strong technical reason why we wouldn't, if there's a strong requirement, support some of those features for YCQL also. Yeah. I shouldn't commit here saying, what, I don't know exactly where it is in the roadmap, so I need to be careful what I say. But let me I think there are a few more questions. Do the clusters need to be at the same software level? I believe that's again a temporary restriction with some of these enhancements that we require the number of tablets and number of nodes to even be the same, but those are really, really short-term restrictions with these enhancements. As a distributed system, we do fully anticipate that, these nodes can be on slightly different releases. You might have upgraded one to a newer release. We should tolerate like difference in number of nodes and so on. But as of now, for some of these new features, yes, there are some restrictions. Let me just mine some of the other questions. Does xCluster support source and target with different topology? Yeah, same answer, not for the older version, just for these enhancements, it's a temporary restriction. Is that fair, Val?
Yeah, and those restrictions will definitely be lifted, like in the GA version.
Yeah, if all you needed was sort of single shard atomicity and the older version of xCluster is sufficient. So these are strictly enhancements that are sort of under, it's like a preview a tech talk you could imagine, right? Okay, and let me just see if I missed any other question. Okay, somebody said kudos for implementing xCluster, which is missing functionality from some of the leading database vendors. Yeah, really appreciate it. This is kind of like if you're in the Oracle world, you're used to Golden Gate, but with distributed databases, it is a very hard problem. Not everybody wants to do a 3-region synchronous deployment. People do care about, there's a whole bunch of workloads that need the latencies on the single cluster to be small. So they want async replication capability. So definitely it is big important feature and also a technically challenging one. So yeah, really kudos to the engineers who've been working on this. There is an earlier version of this tech talk also, maybe from 5-6 months back. That one was before we had some of these feature enhancements related to transactional atomicity and global ordering. And there was another question, does xCluster support filtering or subsetting? Like, I guess you can take the question at 2 levels. Can I just choose subset of tables, or I don't know if the question means like rows, but Val, why don't you cover that? Yeah,
so I think like the short answer is here would be no. Like what we do is like on the database level, the replication set up on the table level, right? However, like we're actually for disaster recovery, especially, we're leaning towards like a database level scope, meaning that you like specify that you want to failover capability for a certain database or a group of databases, and that's the scope of disaster recovery. But and there's definitely no filtering like on the role level.
Yeah. Thank you, Val. Keep going, yeah.
All right. Yeah. So, and after you do the PITR, and you can actually switch the standby cluster to your active cluster, right? So you promote the formerly standby to active, and then you resume the applications, right? So this is the unplanned failover. So it's kind of similar to planned failover, except we don't wait for the replication lag, but instead we have to apply PATR to restore to the save time. Also, a quick note on estimated data loss estimation. Estimated data loss estimation.
That's all right. It's a
on
fun
estimating the potential data loss that you might have in case of unplanned failover. So what happens is that there are two components to that, right? So first of all, there is just the replication lag, right? So when there is a failure on the active, there is some data that was still in the queue and was not replicated. And also there is another metric that we added, which we call consumer save time skew. That is on the standby side. So this is like essentially the difference between the actual save time and the maximum save time across all the tablets, right? So the save time skew is what you lose when you apply PATR, right? So, and important, like coming back to the replication lag, it's important to note that it's not available after the failure. So the typical approach is like to monitor the replication lag, and so that you know the latest value that was before the failure, and then combine it with the current save time skew, and that would give you the estimated data loss. The importance of this is important because you might, depending on what the data loss would be in case of you actually go through the failover process, might influence your decision on whether you actually want to do failover or not, right? In some cases, if the estimated data loss is too large, you might want to take the downtime and just wait for the cluster to come back up and rebootstrap the data, right? Reload the data. So this is just how you do the estimation in case of unplanned failover. So also important aspect of disaster recovery is how you deal with schema changes, right? And there are several things here. So first of all, adding table or index. And also I'm mostly bringing this up because the process is going to change in the future. So currently there are some manual operations that you need to do in case you add a table, for example. So in case of adding table, you have to execute the create table or create index statement on both clusters, active and standby, and then also manually add the table to the existing replication. Important to note that if it is highly recommended that you do that before you start adding any data into that table, because otherwise you will have to do a bootstrap of the whole database. The bootstrap process is database scoped. It does the full backup restore of the whole database. So it is highly recommended that you do all the 3 steps before you start to add any data into that new table. Altering a table is also something that we improved, and it will also still be improved in the future as well. So when altering a table, you also have to do that on both ends, on both standby cluster and the active cluster. And you can actually do this in any order. We usually recommend to do standby first and then active because it's just kind of less disruptive, but you still can do active and then standby. And what we actually do in that case is that we automatically pause the replication when you execute the alter table on the active cluster, and resume the replication when you do the same alter table on the standby. So the database will kind of monitor the schemas on the both ends of the replication and make sure it's consistent. Prior to that, you would have to do the pause and resume manually, and it was a very manual process and quite error prone. So there is some improvement there in 2017. And finally, yeah, so again, this is an active project. It's currently, as Kannan said, it's in preview. It's not production ready by any means. And there is a lot of stabilization ahead of us, but also a lot of new additional improvements as well. So first of all, read-only mode, I mentioned that this is definitely what we want to see for the standby cluster, but it's not there yet. This is the active work in progress. Then the ability to set the role on the replication level. So currently it's cluster level, but we want to do this more kind of granular so that you can, for example, replicate one database to US East and like maybe another database to some other data region, right? So you create kind of a failure groups in a sense with different databases and fail over them independent. DB level replication, so that's the improvement to the process of adding new tables and indexes, so that they would be automatically enlisted into the replication, right? So you execute create table and the tables, and the table is automatically replicated. Automatic DDL replication, this is just meaning that you only execute DDL commands on the source, on your active cluster. And that's all you need to do, right? Regardless of whether you need to create a new table or you need to do the alter table or drop the table, you just execute that on the active cluster and the database take care of the replication of the actual DDL command. Quick failback based on PATR. So this is related to unplanned failover, right? So after the unplanned failover, you want to have a standby cluster, right? Added to the new active. So in the current implementation, what you would do is you would essentially create your standby from scratch, right? So you would wipe out the data from the old cluster and reload the data, or you can create a standby from scratch, maybe even in some other region, right? We can, so we have an idea of implementing a mechanism based on PITR. So instead of doing that, you would restore your formerly active cluster to the same save time based using PITR, right? So that is just for quicker failback process. One-to-many replication is also on the roadmap. This is just meaning that, so currently it's limited to one-to-one, right? So you can have only one standby essentially. You will have an ability to have multiple standbys and YSQL support. So yeah, we discussed that this is currently the transactional support is for YSQL. So YSQL support is hopefully coming in the future as well. All right. I also have a quick demo. Do we have time for the demo?
Yeah, I think yeah, let's go for it.
All right. Okay. Yeah. I'll share. I just need to share the whole thing. Okay. Yeah. So here I have like a very basic setup with two clusters which I created using YB Anywhere, but you can do the same setup using like the command line APIs as well. I have two clusters. One is in the US West region and another is in the US East region. And I also do have the replication setup. Sorry. I have both replications also set up, east to west and west to east. So as I mentioned, you need like the bidirectional setup. Only one will be used at any point in time, but we need both for the failover. Okay, so now let's go to the terminal. So this is like on the left is my west cluster, on the right is my east cluster. So I will, and I will already have like a table, a very basic schema. I have very basic schema for this, which is just a single table called balances, and it has an ID, name, and a balance, right? And there are several people there in the table. And the same thing is on the other side as well. So if I run the same exact query, we'll get the same result, right? And also, of course, if we calculate the sum of all the balances, we'll of course see the same result as well, which we expect. So now let's run some workload, right? I'll look at from here. I have a script which is called transactions sh, which is a very simple script. What it does is it picks 2 random IDs from 1 to 10, which is our data set, and executes a transaction where it gets some money from one of the accounts and puts the same amount to some other account, right? So this is very basic thing. I will
essentially you're showing a multi-row transaction where previously we would have had temporary states where the total doesn't add up because it, at least in xCluster, it was not atomic. Is that the idea?
Correct. Yes.
Okay.
I will. Yeah. This is to demonstrate like atomicity. I'm just making sure that both clusters are active. So here, like what I'm doing is I have both clusters in the active role, right? Meaning that they both will read from the latest time rather than save time. So atomicity is not preserved. So this is like what you would have in the actual like active setup, right?
This was like the older behavior of xCluster.
Correct. Yes. So this demonstrates the older behavior. So if I just run the transactional script, so it will do a bunch of commits. And here I also have check script, which all it does, it just executes select sum balance in the loop. That's all it does. So I'll execute this one on the other side. Okay. What I can actually do is, hold on. I don't know why script doesn't work, but what I can do, I guess, is just do this manually. Because if I execute this multiple times, so you see there is like a different number sometimes, right? So this one was different from this. So sometimes it's of course will be correct because there's not many updates. And
yeah, you have to catch it fast. Like, yeah, you do one time the number was different.
Right? Yeah, I mean, when I do this manually, it's harder to catch, of course. Like if it goes in the loop, it will.
Can we go to line 3 of your script, see what it's complaining about on the check.sh script?
Yeah, it says no such file or directory, which I'm not sure.
Can you open your check.sh file? One, two, three. Yeah, just remove all the tilde and all that. I think you can just say dot YSQL.sh because you're already in the directory where YSQL.sh is present, right? So remove tilde master bin and put a dot there.
I can do that. I can,
yeah.
Because I probably not in that directory though, but I can move to that directory. So yeah, so if I copy the
because I think you aliased YSQL.sh to something. Is that the problem? Anyway, let's try this.
Yeah, maybe. Hold on. Master bean, and I just do check. No.
Is there a YSQL.sh in the location where you are?
Yeah, it is. It is there. And yeah, that is weird. Like it actually worked for me. Yeah, I'm not sure.
Okay.
Yeah, so the command is here. Yeah, I don't know what happens to be honest. But yeah, so I think we've seen
maybe sh instead of bash, just say sh space check.sh.
No, same thing.
Okay, let's not try to, okay. Okay, so
that is really strange. I'm sorry about that. Yeah, so if I stop this, so what will happen? Let me just, I guess, show what is supposed to happen, right? So as I said, right, so these 2 clusters are now in active mode, both in active role. which essentially kind of demonstrates the old behavior. So to finalize the setup and enable the transactionality, we need to switch our US East cluster to the standby role, for which I use the change xCluster role mode. And it says changed role successfully. So now if I run the same workload, right, so I can rerun the workload. So let's just try to run this manually a bunch of times. In this case, like, we're not expecting different results. And we should always see like the number that is the sum. And it's not going to change. That is the number that we've seen initially, because we're not changing the total sum of the balances, obviously, because we're just transferring some amount of value, some amount of money in every transaction. Yeah. So yeah, I'm sorry that the the check script didn't work, but that's.
Can you print your aliases? Like, I think you aliased YSQL SH to something. I don't know, or maybe the quotes.
Yeah, no, it might be because of that, but yeah, I don't know. It worked for me yesterday when I prepared this. Not sure what happened today.
All right. I think there was one final question. Can we set different TTL at the source and target cluster? I think it was answered there. There are ways to, yeah, I think that's generally not recommended for the same table, setting different TTL. That's sort of like outside the scope of the xCluster. In general, would not recommend changing that TTL on both.
Yeah, at least currently. Like, if there is any particular use case that you are thinking of, feel free to go to our Slack channel, and we can discuss. Because I'm definitely curious to know about what you're looking for. But currently, no. Like, the schema has to be the same on both ends.
Wonderful. Thank you very much. Well, thanks everyone for joining us today on this episode of the Friday Tech Talk, and see you all on another episode next week. Thank you.
Thank you, everyone.